Good day everyone, I'm Margaret Dela Cruz from CED 10301P and I will be presenting about Gauss's law. So without further ado, let's dive in right away. First, what is Gauss' law? So Gauss' law is a fundamental principle in physics, specifically in the field of electromagnetism. It describes the general relation between the net electric flux through a closed surface and the charge enclosed by the surface. And the one who formulated this law is none other than Carl Friedrich Gauss. He is a German mathematician and a physicist, thus it is called Gauss's law from his surname. So mathematically, the expression of this law is expressed as the one that you can now see on your screen. So the electric flux through a closed surface is the electric magnetic field integrated over the surface area, and it is equals to the total charge enclosed by the surface and over the epsilon naught, or the permittivity of free space, a constant in the equation of electromagnetism. So, in simple terms, Gauss's law states that the total electric flux through a closed surface is equal to the total charge enclosed by the surface divided by the permittivity of free space. So, one of the powerful aspects of Gauss's law is its ability to simplify the calculation of electric fields in certain symmetric situations. If the electric field has a high degree of symmetry, for example, spherical, cylindrical, or planar symmetry, Gauss's law can often be applied to find the electric field without having to perform detailed calculation at every point. And this makes it a valuable tool for solving practical problems in electromagnetism. Now let us have a deeper exploration of this law, which is the Gauss law. So first, you can look at the figure that is now showing on your screen and just follow on my explanation. Okay, so first let us consider a positive point charge, which is represented by small letter q, is located at the center of a spherical surface of radius. There. The field lines radiate outward and hence are perpendicular to the surface at each point. So the broken lines, as you can see from the point charge, which is the letter Q at the center of the sphere, is sinasabi na it radiates outside or outwards the sphere, and that is the field lines there. So at each point on the surface, the electric field is parallel to the vector, which is the surface area, representing the local element of area. Therefore, at all points on the surface, it is now, as you can see on your screen, which is the formula of this for this problem. So again, the electric field integrated to the surface area is equals to component of the electric field perpendicular to the surface and the local element of area, and also equals to itself there. And from the equation of 19.15, from this equation, which is the electric flux is equals to the electric field also integrated to the surface area is equals to electric field to the surface area. So from the equation, from that one, from this equation, it will turn, or we can now find the net flux through the surface is the electric field is equals to the component of electric field perpendicular to the surface integrated in the surface area is also equals or perpendicular to the E, which is the constant, and the surface area. Thus, makukuha nila yung answer, which is this constant letter E and the surface area. So, because nga, letter E is the constant over the surface, we know that the magnitude of electric field everywhere on the surface of the sphere is E equals to the kinetic energy Q divided by the radius squared. And that is from the previous lesson. So furthermore, for the spherical surface, which is it represents the letter A, it is equals to 4 pi radius squared, or the surface area of a sphere. Hence, the net flux through the surface is now represented as V constant E, and the spherical surface or the surface area of a sphere is equals to the kinetic energy of VQ, which is the point charge at the center, divided by the radius squared, and it will be multiplied by 4 pi or radius squared, which is the surface area of a sphere, and it will come up with a product of 4 pi kinetic energy with the point location, which is represented by small letter Q. So recalling that kinetic energy is 1/4 of pi, electromagnetic field, we can now write this expression in the form of the original or the formula of Gauss's law, which is the electric flux across any closed surface is proportional to the net electric charge Q enclosed by the surface, where the 3, 1, and 0 is the electric permittivity of free space. So, to simplify, electric field is equals to it is proportional to the charge Q at the center inside the surface over the permittivity of the free space. There. So now we can say that this law this result mathematically represents that the net flux is proportional to the number of the field lines. Second is the number of field lines is proportional to the charge inside of the surface. And lastly, every field line from the charge must pass through the surface. There. So that is all for the Gauss's law. Thank you very much.